Here's one more inequality using AND. We're asked to find a solution to 2x greater than or equal to 0 and 4x minus 1 less than or equal to minus 9. So we need to solve these for x first. Here we divide both sides by 2. We get x is greater than or equal to 0. And on this side here, what we would do is add 1 to both sides. So minus 9 plus 1 is minus 8. And then divide both sides by 4 to get x less than or equal to minus 2. So we want the solution to x greater than or equal to 0 and x less than or equal to minus 2. X greater than or equal to 0 would be all these numbers here to the right of 0. And since there's an equal sign there, we could use a bracket right at 0. And then x less than or equal to negative 2, well, we start at negative 2 and we go less than. So we go to the left. Again, we use a bracket here and go to the left. And we want to know where do they overlap. And from our drawing, from our graph on the number line, we see they don't overlap. And so in this case, this doesn't have a solution. And so we would say no solution to this compound inequality. Sometimes you're given an inequality without any words. Here's one that says find a solution to 4 less than 8 minus x less than 10. Essentially, we actually have two inequalities here. What do we have? We have 4 less than 8 minus x, and we also have 8 minus x less than 10. And so we would want to solve these each for x and find the solution, the intersection, if there is one. However, you can also solve it as written up here without having to do two separate inequalities. And the way to do that is apply the same operation to all three parts, like this. So I would subtract 8 from all three parts because I want to isolate the x here. And so we're left with 4 minus 8 is negative 4, less than negative x, less than 10 minus 8 is 2. However, we have a negative x. I need to divide out that negative because I just want x, so we divide everything by negative 1. Now, when you divide by a negative number or multiply on an inequality, the inequality flips. So negative 4 divided by negative 1 is 4. And this less than becomes now greater than. Negative x divided by negative 1 is x. Greater than, this flips, negative 2. So we read this as 4 is greater than x, which is greater than negative 2. In other words, we're really saying negative 2 is less than x, which is less than 4. So x lies between negative 2 and 4. So now we want to graph this. We need to draw a number line, like so. And in our graph we have from negative 2 to 4 highlighted, and that's the solution to this compound inequality. Now we can write this in interval notation. How would we write this in interval notation? We have the set of numbers between negative 2, parentheses, because we're not including negative 2, and 4, close parentheses, we're not including 4. Now you have to be careful here. This particular set of numbers here is a set of numbers. This is not a coordinate point. So sometimes there are ambiguous notations in math, and you have to read it in context. The context of this particular problem, this is the solution to this compound inequality, and so this is an interval of numbers between negative 2 and 4. Now let's look at some OR compound inequalities.